So now in the second semester the inorganic topic, so block 2. So block 2 again M.Sc inorganic chemistry. A unit next 5. The 5th unit 5. The unit 5 is so block 2 the again SEM. So inorganic chemistry unit 5. So unit 5 is, what is the introduction? Introduction of coordination compounds, general characteristics of coordination compounds, and what are the terminologies involved or used in coordination compounds. We are going to study about terminology used in coordination compound. So now in the introduction, so coordination compounds have been studied extensively because of their coordination compounds have been studied extensively because of their unusual chemical nature and useful properties. So useful properties, unusual chemical properties and unusual chemical nature and useful properties. So generally coordination compounds are classified. So coordination compounds are classified neutral molecule, positive or negative molecule. So coordination compounds are classified usually neutral molecule, positive or negative molecule. They are classified as 3 types. So for example, I will take one example for coordination compound. I will give best example for coordination uranium. So this is uranium complex, hexafluorouranium. So this is a complex. This hexafluoro complex. These 4 uranium are in the dotted lines plane. This is above the plane and this is below the plane. So this is neutral hexafluorouranium. This is a neutral, no charge, no net charge. This is a neutral complex. So complex and neutral complex. Nodi dotted line and barದಿದ್ದೀನಣ್ಣ ಇದು 4 ಕಾರ್ನರ್ ಪ್ಲೇನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ on the plane. This is 2 fluorine are above the and below the plane. This is above the plane, this is below the plane. This is neutral complex. So neutral complex. So in case of positive, nickel H2O is present. This is cationic complex. The cationic complex parenthesis celebrate is plus 2. So I have to represent structural formula for like this one. So this here, this is 4 water molecules are in the plane. This is above the plane and this is below the plane. So this complex hexa aqua nickel plus 2 complex. This is a complex after writing this like this parenthesis. So this type of bracket. So this is neutral. Already written this structure. So uranium. So hexa fluoruranium. This octa hexa aqua nickel plus 2. So this is hexa aqua nickel 2 complex. Nickel 2 complex. So this is the name. And this is the structure of nickel. So this is nickel. So I will take one more example for complexes. Anionic complex. Anionic complex. Anionic complex. So this anionic complex is iron, is cyanide, and this cyano group. This is also cyano. This cyano. And this is cyano. So it is hexacyano anion. This charge, net charge is 3 minus. So this is minus 3. This is the complex. So this is hexa. Total 6 cyano group is there. That's why hexa cyano ferrate. I will tell you what is ATE chem ferrate. Hexa cyano ferrate 3. Ferrate 3 complex. This is the example for anionic complex. So this is also these 4 ligands are in the plane and this is above the plane. This one is below the plane. This is below the plane. There is 3 types. One is neutral complex and cationic and anionic complex. We have seen example for each one. What is coordination compound? Coordination compound. What is coordination compound? So coordination compounds are those containing single metal atom. In general, this is M or A, general metal atom, or ion, nickel 2 plus is an ion. So nickel 2 plus is an or ion surrounded by monodentate ligand. So ligand surrounded by monodentate ligand. This is the one type. So this is octahedral. It is octahedral because of 6 ligands. So central atom surrounded by monodentate ligand. So example I have already written. This is ligands. This is ligand. This is an example for coordination compound. What is coordination compound? A metal is surrounded by monodentate ligand. Then it is called coordinated compound. So most of the coordination belong to the class. So this is complex. What is coordination compound? Coordination compound is a metal surrounded by a metal or ion is surrounded by monodentate ligand, then called coordination compound. Then it's called coordination component. The next, what are the terminology used in terminology used in coordination compound. What are the terminologies used in the coordination compound? Coordination entity, coordination entity. The first is coordination entity. So it is an ion, the ion surrounded by, for example, already I told this ion is surrounded by water, in water. Ion is surrounded by water. Means ion is surrounded by 3 ammonia and 3 chloride ion. 3 ammonia and 3 chloride ion. Here ion is surrounded by 6 water. Here in this example, ion surrounded by 6 water molecules. The coordinated entity constitutes central metal ion. This constitutes central metal ion or ion bonded to fixed number of ions or molecules. So coordination entity means it's a central metal ion. It's a central metal atom or ion bonded to a fixed number of ions or molecules. Fixed number of ions or molecules are called coordination entity. The next one, central atom. This is very easy. This central atom means the atom surrounded by ligand. Central atom. Terminology: central atom or ion. Any atom, any coordinated atom is surrounded by ligand. So I am taking octahedral complex. So this is a central atom. It is surrounded by ligands. This is a central atom. What is coordination number? Coordination number. It is the number of ligands surrounded by central atom. The total number of ligands attached. The total number of ligands attached to central metal ion in the given complex is called coordination number. Here total 6 ligands is there. So that's why it is octahedral. The coordination number, the number of ligands surrounded, the number of ligands attached to central atom is called coordination number. Here coordination number is 6 because total ligand is 6. Total number of ligands attached to the central metal ion in the given complex is called coordination number. Next terminology, coordination, polyhedral. So it is actually same with the ACCL it's a complex, for example. So it's a linear one. So in the it's square planar, for example, nickel tetrachloride. So there is square planar. Cl. So based on on this minus 2. Based on the surrounded ligands, this requires some structure means polyhedral. The most common coordination polyhedral, common or octahedral shape of the complex. Coordination polyhedral. Octahedral is very important. Tetrahedral, and then already discussed this one. Square planar. The octahedral structure of metal is attached to 6 ligands. Metal attached to 6 ligands, then it is called octahedral. If metal attached to 4 ligands, the shape is tetrahedral. It is like tetrahedral, and it is tetrahedral. What is square planar? Square planar means that. So it is square planar. 4 corners different. This is tetrahedral. This is square planar. These 3 are very important polyhedral. These 3 are very important polyhedral. Coordination sphere. Next, coordination sphere. The coordination sphere is the central ion along with ligand, collectively called as coordination sphere. Central metal along with ligand, collectively called coordination sphere. So there are another type is there, important. Homolytic and hetero and heterolytic and heteroleptic. Homolytic and heteroleptic complexes. Homoleptic and heteroleptic complexes. So what is homoleptic? Example: A cobalt, hexaammonium 3. So homolytic because if the central atom is surrounded by same type of ligands, all six ligands are the ammonia. So here in the ammonia, all ligands are ammonia. That's why it is homoleptic. This is hexaammonium cobalt. So this is cation ligand. If cobalt trichloro ammonium 6, then it is heteroleptic because it attaches 2 different ligands. One is chlorine, another one ammonia. That's why it is heteroleptic. The two different ligands is attached to central metal atom. Then it is heteroleptic. All are same ligands attached to central metal atom. Then it is called homoleptic. All ligands all ammonia ligands are same ligand. Ammonia ligands, all ammonia ligands are same. No different ligand is there. Ammonia. 6 ammonia attached to cobalt. That's why it is homoleptic. But here, in this example, 3 are chlorine and remaining 3 are ammonia. So here different is there. Different. Ammonia and chlorine. That's why it is heteroleptic. It is heteroleptic. It is heteroleptic. The bond, metal to bond, bonding, type of bonding, coordination chemistry. This is a metal. If you add bond or ligand, ligands contain pair of electron to donate empty d orbital in the metal. So this is the bonding. So coordinated bond. Pair of electron. Pair. So please listen here. Pair of electron. Shared pair of. So pair of electron donate to the empty metal d orbital. So empty metal d orbital. Then is bonded. After that is bonds. So represents like this. The representation is like this. So this is a ligand. Donate pair of electrons towards metal. So this is complex. This is complex. Metal. Ligand metal interaction. So this is complex. So like that, see this is for example nickel. So if we write the electron configuration, you will get like d orbitals. D orbitals ಬರುತ್ತೆ. empty d orbitals ಗೆ ವಾಟರ್ ಅಲ್ಲಿ ಇರೋ ಲೋನ್ ಪೇರ್ ಏನಾಗುತ್ತೆ ಬಾಂಡ್ ಆಗುತ್ತೆ. So then it is like short pair, lone pair ಎರಡು ಇರುತ್ತೆ. lone pair empty d orbital ಬಾಂಡ್ ಆಗಿ form this structure. So there is total 4 pair electron ಏನಾಗುತ್ತೆ 4 ligands donate ಮಾಡಿ 4 d orbitals ಗೆ ಬಾಂಡ್ ಆಗುತ್ತೆ. That's why it is tetrahedral. TD ಅಂತ ಕರೀತೀವಿ tetrahedral. So this is the formation of coordination bonds. Right, like essentially ಬರೆಯುವುದು two pair of electrons. Third donate ಮಾಡಿರಿ. Pair of electrons from oxygen donated to nickel atom. So tetrahedral. So coordination chemistry ligands ಅಂದ್ರೆ ಏನು? So metal ಅಂತ ಬರೋದು complex ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? What is complex? What is ligand? Ligand is an ion. So ligand is an ion. Ligand is an ion or neutral molecule that binds to a central metal atom by donating one or more electron pair, not electron, only electron pair. Electron pairs to form complex, to form a coordination complex. Ligand is an ion or neutral molecule that binds to a central metal atom by donating one or more electron pairs. So already I told. So in nickel, if you take the example, on any metal, a pair of electrons, for example, is ammonia. It has lone pair. So it's a ligand, a neutral molecule that binds to a central atom, and binds to a central atom by donating one one, if you more is there, no problem. One or more electron pair to form coordination complex. That is ligand. So classification of ligands. Classification of ligands. Ligands types, also called types or classification of ligands. So first one, monodentate ligand. Monodentate ligand ಅಂದ್ರೆ, so monodentate ligand, it donates only one pair of electrons. If water is an example, it donates only one pair, not more than one. So there is ammonia, M.Sc, and primary amine. It has only one capacity, is only one. So ligands having only one donor atom. Sorry, it has only one donor atom. So it is nitrogen. Only one donor atom is there in this ammonia, that is nitrogen. In water, only one atom is there, that is oxygen. Oxygen is donated here. What? Here ammonia again, etc. So bidentate. The ligand contains two donor atoms. Bidentate ligand. So here NH2 methyl CS2OH. So here it has two nitrogens, vessels donated pair of electrons, and also in this case here oxygen. Here both. ಎರಡಿಗೆ ಒಂದು ಆಕ್ಸಿಜನ್ ಇದೆ, ಒಂದು ನೈಟ್ರೋಜನ್ ಇದೆ. ಸೊ ನೈಟ್ರೋಜನ್ ಮತ್ತು ಆಕ್ಸಿಜನ್ ಎರಡು ಆಟಮ್ ಡೊನೇಟ್ ಮಾಡೋದ್ರಿಂದ ಇದನ್ನ ಬೈಡೆಂಟೆಂಟ್ ಲಿಗ್ಯಾಂಡ್ ಅಂತ ಕರಿತೀವಿ. ಓನ್ಲಿ ಒನ್ ಆಟಮ್ ಡೊನೇಟ್ ಮಾಡಿದ್ರೆ ಮಾಲಿಕ್ಯೂಲ್ ಅಲ್ಲಿ ಅದನ್ನ ಮೊನೋಡೆಂಟೆಂಟ್. ಬೈಡೆಂಟೆಂಟ್ ಲಿಗ್ಯಾಂಡ್ ಡೊನೇಟ್, ಇಟ್ ಕಂಟೈನ್ಸ್ having two donor atoms are called bidentate. Having two donor atoms are called bidentate ligand. Tridentate or polydentate. Next, polydentate. More than two or more. More than two. Polydentate ligand. Polydentate ligand under listen, does more than 3. So more than 3 is there. So for example, N dimethyl thiocarboxyl. N dimethyl. So here nitrogen and this S and this S. Ethylene diamide, EDTA. You will label EDTA. What is the EDTA? EDTA is ethylene diamide. ES2, this is N, and this is N, and this is N. Ethylene diamide. So this is ethylene tetramine. So this is not EDTA. See, this is total, how many is there? Total 4 ligands. That's why it is polydentate ligand. This is sulfur donate. Here also sulfur is donate. Here this is one example, and this is second example. Total 4. More than 2. More than ligand having more than 2 donor atoms. More than 2 donor atoms. More than 2 donor atoms. 1, 2, 3 is there. 1, 2, 3, 4. More than given in the textbook. Please go through that. So nomenclature. How to name? How to name nomenclature of coordination compounds. How to name the complex molecules? First, if the complex is ionic, the complex ionic agire, name the cation first. First rule. Name cation first. Cation first. Yeah. Cation first. Name cation first. And then second. And then second. Rule number 2. Within the coordination sphere, already told what is coordination sphere. Name the ligands before the metal. Name ligand before metal. Name the ligand before the metal. So name ligands alphabetically. Name ligand alphabetically. So amine before chloro. Andre idu amine irutte complex. Chloro irutte. The first we have to name amine because of alphabetic A. So because of A came first, that's why we have to name A means ammonia first. After that chloro. Fourth, prefixes. Bis, tris, tetrahedral are used for ligands that are bidentate, polydentate are already have a number which is as part of its name. Already name is there. Bis, dimethyl. Correct. A case ಅಲ್ಲಿ ಇಲ್ಲ ಅಂದ್ರೆ ನೋಡಿದ್ರೆ ಅದನ್ನ ಬರೀಬೇಕು. Fifth condition, anionic ligands, ends, anionic ligands is right, anionic ligands, ends in the suffix, O, ends suffix O. So the sixth condition, name of the neutral ligands. So neutral like PA3, phosphine, CO, use carbonine, water na aqua, so amine, ammonia na amine. You name it like that. Amine. That is the name of the ligands. They are given in the chart many ligands. So please go through that notes. I will send you that notes after that. Otherwise, in the page number 103. So an example, So oxidation states always oxidation states here. Oxidation states numerically. Oxidation states of Roman numeral. Roman numeral. Please remember Roman numerals. Roman numerals. When a complex is neutral or cationic, the name of the center metal atom is the same as the element. Example: chromium, nickel, iron. So next, name of the center metal atom neutral is central metal. Name condition neutral or cationic. Central metal neutral or cationic. Name as it is. Name as it is. Like if it is chromium, chromium antane bari. Chromium. Nickel is a neutral or cation. Nickel. This is the condition for naming the. So for naming the complex. So last 9. If anion is there, you end anion ligand with ATE. Anion ligand idre, fluoro idre, fluoro, nitro, yave tara anions ligands idre, have to end ATE. For example, so anion is G-gate. So complex enanadu anion item. Nickel complex anion indicate. So nickelate. I will give two example. So nodidi copper NO2. So cationic coordination sphere. ಏನಕ್ಕೆ cationic coordination sphere ಅಂದ್ರೆ ಇದು ಬಿಡಿಸ್ತಾರೆ copper ammonium 2 so plus 2 oxidation state NO2 minus. So it is cationic sphere. Cationic coordination sphere. Cationic coordination sphere. This is anion. Cationic coordination sphere. So already I told name ligand before metal. Ligand ಏನಿದೆ before metal name ಡೈ ಎಷ್ಟಿದೆ ಅಮೋನಿಯಾ ಡೈ ammonium diamine ಎಷ್ಟಿದೆ diamine ಫಸ್ಟ್ ಲಿಗ್ಯಾಂಡ್ ನೇಮ್ ಮಾಡಿ diamine ನ್ಯೂಟ್ರಲ್ ಇದ್ರೆ ಏನಂತ ಹೇಳಿದ್ನಿ ಕ್ಯಾಟಯನ್ ಮತ್ತೆ ನ್ಯೂಟ್ರಲ್ ಇದ್ರೆ ಕಾಪರ್ ಅಂತ ಬರೀಬೇಕು ಏನಾದ್ರು ನೆಗೆಟಿವ್ ಇದ್ರೆ ನೆಗೆಟಿವ್ ಸ್ಪಿಯರ್ ಆಗಿದೆ ಎಂದು ನೆಗೆಟಿವ್ ಕೋಆರ್ಡಿನೇಷನ್ ಸ್ಪಿಯರ್ ಆಗಿದೆ ATB ಸೇರಿಸಬೇಕು ಮೆಟಲ್ ಸೊ diamine copper. What is the charge? Copper 2 remaining anion that is nitrate. So this is the way you have to name it. It's a cationic sphere. Then I will take one more example, that is neutral. I will take neutral complex. Copper ONO NO2 right. Neutral complex. There is no charge here. This charge is 0. So neutral complex ಆದರೆ already told this is nitro ligand first, dinitro copper, but the charge is inside copper get 2 ಇದೆ, but net complex is 0, neutral complex 0, but metal charge +2. So ನೇಮ್ ಯಾವ ರೀತಿ ಮಾಡಬೇಕು, ನ್ಯೂಟ್ರಲ್ ಸ್ಪಿಯರ್ ಫಸ್ಟ್ ಮಾಡಿ, ನ್ಯೂಟ್ರಲ್ ಸ್ಪಿಯರ್, ನ್ಯೂಟ್ರಲ್ coordination sphere, this is neutral sphere. ಯಾವ ರೀತಿ ನಾವು ಮಾಡಬೇಕು, ligand first and then metal, ligand metal and then oxidation state. ಯಾವಾಗಲೇ ಫಾಲೋ ಮಾಡಬೇಕು. ಫಸ್ಟ್ ಯಾವೇ if they give any complex, ಯಾವೇ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕೊಟ್ಟು ಫಸ್ಟ್ ಮೆಟಲ್ means ligand, dinitro ಎಷ್ಟಿದೆ dinitro, then metal, then oxidation state. So ರೋಮನ್ ಲೆಟರ್ ಬರೆಯೋಣ. ಈಗ ಒಂದು ಎಕ್ಸಾಂಪಲ್, one anionic example I will take. Anionic example K2 CO EN4. So this इधर ಕೊಟ್ಟಿದ್ದಾರೆ, cation ion ಅಂತ ಇನ್ಪುಟ್ ಆಗುತ್ತೆ 2K plus ನಾವು ಬಿಟ್ಸ್ ಬರುತ್ತೆ EN4 minus 2. First it is anionic sphere, anionic sphere. So anionic sphere also first ಏನು metal. So metal ಗಿಂತ ಮುಂಚೆ anionic sphere ಅಲ್ಲಿ ಕ್ಯಾಟಯನ್ ಎನರ್ಜಿ, ಕ್ಯಾಟಯನ್ ನೋಡಿ ಸ್ಪ್ಲಿಟ್ ಮಾಡಿ ಬರ್ತಾರೆ, ಡಿಸೋಸಿಯೇಟ್ ಎನರ್ಜಿ ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ತಾರಲ್ಲ, ಇಲ್ಲಿ ಕ್ಯಾಟಯನ್ ಇರೋ ಫಸ್ಟ್ ನೀವು ಇಲ್ಲಿ ಏನ್ ಮಾಡಬೇಕು, ಕ್ಯಾಟಯನ್ನೇ ಬರೀಬೇಕು. ಇದು ಕ್ಯಾಟಯನ್ ಅಲ್ವಾ, ಇದು ಕ್ಯಾಟಯನ್. This anionic sphere, first write cation and then ligand, cation first ಬರೀರಿ, ಆಮೇಲೆ ligand ಬರೀರಿ, followed by metal and then oxidation state. ನೋಡಿ ಈಗ cation ಹೇಳಿ potassium ligand tetrahedral, ಟೋಟಲ್ ಎಷ್ಟಿದೆ ಸೈನೋ, tetrahedral ನೆಗೆಟಿವ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಇದ್ದಾಗ ಮೆಟಲ್ ಏನಾಗುತ್ತೆ, ರೈಟ್ ಎಂಡ್ ATE cuprate 2 complex. ಸೊ ನೆಗೆಟಿವ್ಸ್ ಇದೆ, ನ್ಯೂಟ್ರಲ್ ಮತ್ತೆ ಪಾಸಿಟಿವ್ ಇದ್ದಾಗ ನೋ ನೀಡ್ ಮೆಟಲ್ಗೆ ಏನು ATE ಹಾಕ್ಬೇಕಾಗಿಲ್ಲ. ಬಟ್ ನೆಗೆಟಿವ್ ಸೈನ್ ಇದ್ರೆ ಏನ್ ಆಡ್ ಮಾಡ್ಬೇಕು ನೀವು, ATE ಆಡ್ ಮಾಡ್ಬೇಕು. ಸೊ ದೀಸ್ ಆರ್ ದಿ ಕಂಡೀಷನ್ಸ್ ಇದೆ ನೋಡಿ. anionic ligands ಆದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು, ಓ ಸೇರಿಸಬೇಕು. ಸಿ ಸೈನೋ ಏನೇನು ಅದೇ ದಟ್ ಬೈ ಓ ಸೈನೋ ಇದು ಅಷ್ಟೇ. ಇದು ನೆಗೆಟಿವ್ NO2 ಮೈನಸ್ ನೆಗೆಟಿವ್ ligand. That's why dinitro have to end with O, negative ligand. For neutral water, ammonia, there is no need for adding O at the end. No need to add O at the end. Neutron complex is like this: cobalt, ammonia, fluoro, 3. First alphabetical ಪ್ರಕಾರ amine first ಬರುತ್ತೆ ligand. ಆಯ್ತಾ, ಟ್ರೈ amine, ಆಮೇಲೆ ಟ್ರೈಫ್ಲೋರೋ, ಸಿ ಆಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಟ್ರೈಫ್ಲೋರೋ, cobalt, 3 complex. ಫಸ್ಟ್ ಆಲ್ಫಾಬೆಟಿಕಲ್ ಆರ್ಡರ್, ನ್ಯೂಟ್ರಲ್ ಅಂದ್ರೆ ಆಲ್ಫಾಬೆಟಿಕಲಿ this one. So this is the actually first unit. The first unit. In the next unit, very important is valence bond theory. Valence bond theory. Valence bond. Valence bond theory. So it is a valence bond theory was proposed by Pauling. The Pauling, it is mainly based on the concept of hybridization. Hybridization of suitable orbitals of the metal end. The following assumptions are put forward to explain this theory. So first the metal atom, or ion as available metal d orbital. Metal d orbital as available metal d orbital, which equal to its coordination number, which is equal to its coordination number. Coordination number for accommodating the pair of electron, accommodating the pair of electron from the ligands. Right? Metal d orbital so ಎಷ್ಟು ಇರುತ್ತೆ ಅಷ್ಟು ಏನಾಗುತ್ತೆ ligands accommodate ಆಗುತ್ತೆ. The metal atom has available metal d orbital total ಎಷ್ಟು 5 d orbital ಅವೈಲಬಿಲಿಟಿ ಇರಬೇಕು. ಏನಕ್ಕೆ? ಕೋಆರ್ಡಿನೇಷನ್ ಆಗೋದಕ್ಕೆ. ಯಾವುದು? ಲಿಗ್ಯಾಂಡ್ ಡೊನೇಟ್ ಮಾಡೋಕ್ಕೆ. ಸೊ ಮೆಟಲ್ಸ್ would have empty d orbital. Ligands donate electron. Metal donate ಏನಿರಬೇಕು ಇಲ್ಲಿ? empty metal d orbital ಇರಬೇಕು. The first condition. The valence bond theory. Valence bond theory, the first feature is there is available the metal d orbital for accommodating number of ligands. The first assumption. So usually metal uses sp-d orbitals. Metal uses sp-d orbitals for accepting ligand. It uses D, this is P, 3D, 4S, 4. For accepting ligand electrons, it uses these 4 orbitals. See, second assumption for valence bond theory, ligand electron donate ಮಾಡಿದ್ರು. ಸೊ ಏನಿರಬೇಕು ಮೆಟಲ್ ಅಲ್ಲಿ ಎಕ್ಸೆಪ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಆರ್ಬಿಟಲ್ಸ್ ಇರಬೇಕು. ಆರ್ಬಿಟಲ್ಸ್ ಯಾವ್ಯಾವ ಅಂದ್ರೆ 3D, 4S and 4P. These are the orbitals is available to accept electrons from the ligands. Second assumption. So in the third assumption, ligand have at least one sigma donor. At least one sigma donor orbital. At least one sigma orbital one sigma donor orbital containing lone pair. One to lone pair ಇರಬೇಕು again containing one, at least one lone pair ಇರಲೇಬೇಕು. One lone pair of electrons. One lone pair of electrons. Again have at least sigma orbital containing lone pair of electrons. Lone pair of electrons. So this is third condition. The fourth condition, so ligand donate pair of electrons and metals will accept this pair of electrons from the ligand. This from the ligand, that is sigma bond. This is called sigma bond ಅಂತ ಕರೀತೀವಿ. Vacant hybrid orbital ಇರಬೇಕು. SED vacant hybrid orbitals ಇರಬೇಕು. The d orbitals used in this nd or n-1 d orbitals. Inner orbital ಅಂತ ಕರೀತೀವಿ. n-1 ಯೂಸ್ ಮಾಡಿದ್ರೆ inner orbital, nd ಯೂಸ್ ಮಾಡಿದ್ರೆ outer orbital. We will tell you later how it is inner and outer. So this ours follows Moore's rule while splitting this d orbital, and this is s orbital, and next is p orbital. It follows what? Moore's rule. Singly occupied. Presence of unpaired electrons in the complex given rise to ferromagnet. So singly occupied. Moore's rule should follow. Moore's rule to fill ligand in the orbital. Also, next, so magnetic momentum, more magnetic momentum can be calculated by the formula root 2 into n plus 2 Bohr magneton. Root n into n plus 2 Bohr magneton. So magnetic properties can be calculated. Magnetic properties. These are the assumptions are given by the valence bond theory. According to valence bond theory, it is very interesting. Valence bond theory is very interesting. Interesting is that the octahedral complex are formed by D2sp3 hybridization. D2sp3 hybridization is called inner orbit. Inner orbit. If sp3d2 is outer orbit, why it is inner orbit and why it is outer orbit? Hybridization. First I will take this one, inner orbit. First I will take inner orbital. Inner orbital complex. Outer orbit and inner. Very interesting. So interesting like that. For these complex, the inner d orbitals means n-1 already got d orbitals used here. Form hybrid orbitals with ns and np. np orbitals for bond formation. See, first one example from the hexaammonium chromium 3 plus complex. So, if I write the chromium to atomic number is 24. Electron configuration bari. Chromium the electron configuration. Ground electron configuration bardara 3D ಕರೀತೀವಿ ನಾವು. This is 3D and this is 4S. This is 4D. 3D orbital ಅಂದ್ರೆ ಎಷ್ಟು ಆರ್ಬಿಟಲ್ಸ್ ಇರುತ್ತೆ? 5. S1 P3 electron configuration it has like this electrons. 5 electrons in the chromium atom. Chromium atom is still than 5. In this case 1, case 2 is chromium atom loses how many electrons? 3 electrons to form complex. Right? Oxidation state 3 carbon. 3 electron ಹೋಗುತ್ತೆ. Remaining ಎಷ್ಟು ಬರುತ್ತೆ? Chromium 3. Actually this oxidation number of metal is M. Metal X ಅಂತ ತಗೊಂಡ್ರೆ plus how many is there? Charge is neutral, net charge is 3 plus amount in the charge is 0. Neutral molecule, that's why total number of reagents is 0. X equal to 3. So what is X? Oxidation state is plus 3 complex is complex. The complex plus 3 is 2 electrons ಇರುತ್ತೆ. Actually round shell ಈಗ oxidation 3 is ಈ complex position ಈಗ 2 electrons ಇರುತ್ತೆ. So this one 1, 2, 3, 4, 5, 6. ಆಯ್ತಾ? ಇದು actually ground state. After losing 3, 1, 2, 3, it has excited plus 3 oxidation state. Chromium plus 3 oxidation state. ಆಯ್ತಾ? ಈಗ ಇದಕ್ಕೆ ನೀವು I have added ligand, attached ligand, 6 chromium ligand attachment. 6 chromium ligands na attachment 1, 2, 3, 4. ಎಷ್ಟು 1, 2, 3, 4, 5, 6 ನೋಡಿ ಇದು ಈ 6 pair of electrons ಎಲ್ಲಿಂದ ಬಂತು from ammonia. ಅಮೋನಿಯಾದಿಂದ ಲೋನ್ ಬೇರೆ 2 ಎಲೆಕ್ಟ್ರಾನ್ ಹೋಗಿದೆ ಅಮೋನಿಯಾ. These 6 are in ammonium. NH3 and this NH3 6 ammonium molecules empty 1, 2, 3, 4, 5, 6 ಕೊಟ್ಟಿದೆ ಅಮೋನಿಯಾ. And this is the bonding. See, ಈ ಅಮೋನಿಯಾ ಇದಕ್ಕೆ ಅಮೋನಿಯಾ. See, 1, 2, 3, 4, 5, 6. So each ligand. So what is ligand? Donate pair of electrons towards empty orbitals of metal. Metal ಗೆ ligand ಏನು ಮಾಡಿದೆ? ಡೊನೇಟ್ ಮಾಡಿದೆ. ಎರಡು electron donate ಮಾಡಿದೆ. So this is types of, see in more. Carbon is a strong ligand. Nitrogen, except cobalt 3 plus, acts as weak ligand. This carbon containing ligands, how do you carbon ligands containing ligands are strong ligands. This petrochemical series, we already studied this petrochemical series. Strong ligand, carbon containing is very strong. These are weak ligands. Nitrogen, oxygen, fluorine containing ligands are weak ligands. See, nitrogen in chromium case weak ligand. It cannot force these electrons to pair. ಈ ಪೇರ್ ಆಗೋದಕ್ಕೆ ಏನ್ ಮಾಡುತ್ತೆ ಅಮೋನಿಯಾ ಫೋರ್ಸ್ ಮಾಡಲ್ಲ ಬಿಕಾಸ್ ಆಫ್ ವೀಕ್. ಇಟ್ ಲೆಫ್ಟ್ 3 ಇನ್ ದ ಅನ್ಪೇರ್ಡ್ ಓನ್ಲಿ. ದಟ್ಸ್ ವಾಟ್ ಇಸ್ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್. ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಅಂದ್ರೆ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಪ್ರೆಸೆಂಟ್ ಇದ್ರೆ ಅಂತ ಪ್ಯಾರಾಡೈಮ್ಯಾಗ್ನೆಟಿಕ್ ಅಂತ ಕರೀತಾರೆ. ನೋಡಿ ಅಮೋನಿಯಾ ಬಂದಾಗ ಇದು ಈ ಕಡೆ ಶಿಫ್ಟ್ ಆಗಿ ಏನಾಗಲ್ಲ, ಪೇರ್ ಆಗಲ್ಲ, ಅಲ್ಲೇ ಇರುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಅನ್ಪೇರ್ಡ್. ಸೊ ದಟ್ಸ್ ವೈ ದಿಸ್ ಇಸ್. ಸೊ ಈಗ ಹೈಬ್ರಿಡೈಸೇಷನ್ ನೋಡಿ, ಈಗ ಏನಿದೆ D2 ಇದು 2 D2 ಇದೆ. This is how many is used? 3. So that's why it is D2 sp3. D2 sp3. So D2sp3. The complex is what? Octahedral hybridization D2sp3 ಇದ್ರೆ ಯಾವುದು D2sp3 ಇದೆ, that is inner sphere ಅಂತ ಕರೀತೀವಿ. D2sp3 ಕಾಂಪ್ಲೆಕ್ಸ್ ಇದ್ರೆ ಅದು inner sphere ಆಯ್ತಾ. The complex is paramagnetic because unpaired electron is there. That side is paramagnetic. D2sp3. These are the current features of the complex is octahedral. This also supported by experimental data. Experimental data ಪ್ರಕಾರ complex ಕೂಡ D2sp3 ಇದೆ, ಅದರಿಂದ ಇದು there is okay. Now, I'll take one more example for the inner sphere again. For this inner sphere, the outer sphere actually the next. Outer sphere, that is sp3d2. Why it is sp3d2? sp3d2. I'll take this example. Hexafluorocobalt 3 minus negative charge. So cobalt atom का पर्दा ground state, right? Ground state for cobalt is 3D and use P. This is P. This is 3D